Let's consider this case. First, what do? You consider a rubber tube. Let's consider a rubber tube. Of Poisson's ratio for rubber. What do is you first consider a rubber tube and let it hang over here, let's say, with certain stand. Actually, you have certain stand and you are holding this rubber tube at this point. Let's say this is the top and you have certain amount of cork is sitting over here. And apart from that, what do you have? You fill this rubber tube with water. Clear? And you place a capillary tube over here. You put a capillary tube over here, which is open on both the end, over here also, as well as over here. Now there is certain reading on your capillary tube. Clear? As it is filled with water, then what? The water will start rising. Then overhead at the bottom, you have certain amount of weight which is hanging over here. Clear? Is it clear there here? Any doubt? Now as you see, this part is filled with certain amount of water. Then what will happen? The water will start to rise. Clear? Let's say initially the water has rise till here. And it has reached a certain steady state. That means a certain reason the water will stop flowing at this point. Now if you put the weight, then what will happen? The volume will change. So that's why what? The water will rise or it will come down. So initially it was sitting over here. And you start making a reading. Let's say it was at certain x, let's say. Now what do? After this, you add more weight over here. You add certain amount of weight over here. Then after that, what will happen? It will get elongated. The tube will get elongated on this side, but get compressed on this side. As a result of this, what? There is a change in volume. Then what will happen? The water will fall. Usually the volume changes. This is the initial reading. Now let's say the water has, due to certain amount of weight, let's say this as W2, then what will happen? The level of water will come down. Now it has reached certain point over here. Let's consider this as X2. Now X is greater than X2. Now due to a change in volume of this rubber tube, what will happen? The water will come down. The water level will come down. From that, you will be able to what? Determine the Poisson's ratio. Because there is basically the change in volume. Initially, the volume was of this, and after that, the volume has changed to this. Let's say the volume was V. Now it has went to V2. Let's write this as V1. Now it has reached to V2. Now from this relation, we are going this too. Now let's consider the tube has initially the tube has a diameter of what? Length of the volume is given by what? Area into length. cross section. Basically, this is the area of cross section. If the rubber is cylindrical in shape, the volume will be what? The area of cross section will be pi r square, and length is what? L. So this is inverse. Let's call it. Now, after you have put some weight, is what? V plus dV, basically. Now, after on your lateral side, but on the longitudinal side, it has stress. So that's why we are getting negative. Now, if you take now the change LDA and minus DA DL. Now, what we can do is we will neglect this term. Neglect this term. Why? Because this is in second order. Which means that the even the change is extremely small. So from here we can write what V plus dV is equals to AL plus written as what? You can do it in terms of radius also. Actually, it doesn't matter. So let's do in terms of diameter. D square divided by 4. This is your area of cross section. So your dA will be what? If you take a differentiation of this with respect to diameter, because we want dA, so it will be twice pi d divided by 4. 2 2s are 4. So basically dA will be what? Sorry, pi d by 2 times of dt. D of d. So we'll substitute this over here. Now we want to write, actually, what do we want to write? We want to get dd by d. Till now, we will call this as equation 1. Now, what we are trying to do is, we want to get dd by d from this area. Now, clearly, one thing we can do is, okay, for timing, let's start from here. So, dA divided by pi d divided by dt. Now, let's divide both sides with d. Capital D will be what? Pi d by 2 by d. Now, this is exactly what we want. This is what here, lateral strain. Now from here we can write this as in terms of area itself. So actually we want LDA. So finally we will get what here, dA is equals to pi d squared divided by 2. We are just bringing it over there. D divided by d. Now if you check over here, pi d squared divided by 2 is roughly equal to this. If you multiply and divide both sides by what? With a factor of 2. If we can write, I think we can write this as dA divided is equals to 2a dd by d. I think this point must be clear to you all. Because what we can do is pi d squared divided by 2 into 2 divided by 2 we can do, and dd by d will be sitting over here. So it will be pi d squared divided by 4. 2 will be sitting over here, dd by d. This is basically a dA, or dA will be how much? Then from here you can easily write this as this twice a dt by d. Now finally we can substitute this in equation 1. So we are left with what? dv equal to a dl minus l. Instead of dA we'll put what? 2a d by d. This is from equation 1. So you can take a common, and also let's take L also common as well. dv equal to, we'll take a and dl common from here, so it would be 1 minus a is already out, 2l, but we have to divide this by dl d by d. So we can divide this on the other side. So it will be what? A dl will be given by 1 minus twice of L by dl and dl dd by dl. Now if we can rewrite this in a slightly different manner. So it will be very visible. Right now it's not that visible, but now what we can do is dd by d, let's put this as this, and this as dl by l. Now it is very visible that dd by d is basically what here? This is here lateral strain, and this is exactly here longitudinal strain. Longitudinal strain. So from here one can get what? dv by a dl will be what? 1 minus twice of, we can write this as new. This is basically new. Or relation for POISS, Poisson's ratio of rubber. This is how you find the Poisson's ratio. Do you have any problem or any questions till now, or is it completely clear? Any doubts? Any doubts?
Sir, voice is
Stop
breaking.
it over here.